Good morning. So let us start chemistry first. Germanium 2 compounds are powerful reducing agents, whereas lead 4 compounds are strong oxidizing agents. This can be due to. So germanium and lead both belongs to 14th group elements. 14th group elements. 14th group means configuration is NS2 NP2. NS2 NP2. 14th group elements. Carbon, silicon, germanium, tin and lead. So down the group, inert pair effect increases. Inert pair effect increases means non-participation of NH2 electrons. NH2 electrons is called inert pair effect. That means NH2 electrons do not take part in the bond formation. Therefore, in case of lead, Pb plus 2 is stable, Pb plus 4 is unstable because NH2 electrons do not take part in the bond formation. Only 2 electrons, that is p orbitals, involved in the bond formation. Therefore, NP4 suppose formed, then has tendency to convert into Pb2 plus. So 4 into 2, decrease in oxidation number. Decrease in oxidation number is called reduction. Process reduction compound is called oxidizing agent. So Pb plus 4 is called strong oxidizing agent. But germanium 2 plus, it has both possible present, both 2 and 4. Inert pair effect in case of lead predominant, but not for germanium. So germanium 2 plus has tendency to form germanium plus 4. Increase in oxidation number is called oxidation. Therefore, compound is called reducing agent. So the question given here, lead germanium 2 compounds are powerful reducing agents, whereas lead 4 compounds strong oxidizing agents, because of inert pair effect very strongly working in the last elements, that is lead, than in the germanium. So answer is 4, which is not observed in nucleophilic addition reactions. C double bond O is called carbonyl group. sp2 hybridization, bond angle equal to 120 degrees. But there is a repulsion between a single bond and double bond. Single bond, double bond repulsion is more. That is called more repulsion between single and double bond. But after nucleophilic addition, it becomes C single bond, OH and Nu. Now it is sp3 hybridization. Bond angle is 109.5 degrees. So 120 changes to 109. Bond angle decreases. Repulsion also decreases because it is single bond, single bond. Single bond contains less repulsion compared to single bond and double bond. The order of repulsion double bond is more than double bond, single bond. That is more than single bond, single bond. So last one is single bond, less repulsions. So bond angle and also repulsions decreases from CO into sp3 carbon formation, that is 120 changes to 109.5. Bond angle decreases, repulsion increases. Wrong. Bond angle and repulsions decrease. I think which is observed. Then both bond angle and repulsions decreases. Correct. Next, free radical substitution of reaction. Bromine is more reactive at secondary because this is primary, it is secondary. So tertiary is more than, secondary is more than primary hydrogens in case of free radical substitutions. So secondary is more reactive. That means here bromination occurs. CH3, CH2, CH, Br and CH3. So this is optically active nature. Chiral center, optically active. So chiral center optically active means it forms dextro and levo or R and S configurations. Both R and S enantiomers, because D and L is taken as enantiomers, indicated by RS notation also, R and S enantiomers. That means both of them formed due to presence of chiral center, that is more reactive is secondary carbon here compared to primary carbon atom. That's why chiral center formation occurs. Next one is phenyl CH2 CH double bond CH2 plus HCl. First H plus ion is added to form stable carbocation CH2 CH plus and CH3, secondary carbocation. Now undergoes hydride shift to form still more stable carbocation. Hydride shift into more stable carbocation. Benzyl CH2 CH3. Benzyl is more stable than secondary carbocation. More stable. So this is called benzylic. So answer 4. Molecular formula of Ab2O4 in which O2 minus forms CCP as met. So O2 minus forms CCP. CCP or FCC, all corners and all face center surfaces. 6 into 1 by 2, 3, 8 into 1 by 8, contribution 1. Effective value 4. So 4 oxides will form 8 tetravoids and 4 octavoids, means octahedral voids. Now in the formula it is given as AB2O4. O4 correct, effectively 4. Now we want one A and 2B. Where is A present? A present on the, that is A plus 2 ions present on the tetrahedral voids. But we want only one tetrahedral void. That means in the case of 8 tetravoids, only one requirements 1 by 8 of 8 tetravoids filled by A plus 2 ions. A plus 2 ions. Okay, 1 by 8 of 8 voids. That means 12.5. This is 4 octahedral voids filled by B plus 3. But 2B requirement, that means half requirement. So 1 by 2 part of octahedral voids filled by B plus 3 ions. That is nothing but 50% and 12.5% respectively. That is 12.5 tetravoids, 50% octavoids. Then 1A and 2B obtained, formula becomes AB2O4. Which of the following highest freezing point present? Depression of freezing point, delta TF, is called depression of freezing point. Depression of freezing point is a colligative property. It is directly proportional to number of particles or ions. Number of particles or ions. That means sodium phosphate 5 ions. Calcium chloride 3 ions. AlCl3 4 ions. urea 1 particle because it is a covalent compound. But to percentage given, then find out number of moles also. So first one, number of moles is equal to mass by molar mass. 5% means 5 grams. Molar mass of the compound Na3PO4 is around 259. So 5 by 259 moles into each part mole contains 5 ions. 5 ions is equal to 0.09 moles of particles. Second one is number of moles is 5 by calcium chloride 111 molar mass into 3 ions. Total value becomes 0.56. Third one is aluminum chloride. 106.5, 15% by 106.5 into 4 ions. That gives 0.56. Last one is urea. Number of moles of urea is 25 by 60 into 1 because 1 particle is equal to 0.42. So least number of ions with respect to mass given mass per means 0.09. Less number of particles, less depression. Less depression means decrease is be less. Decrease is less means resulting freezing point will be more. So less particles contains more freezing point, are also called less depression. Less depression of freezing point. These two compounds contains more particles. More particles, more depression. More depression means very much decreased lowest freezing point for both second and third. But question given highest freezing point, maximum freezing point or highest. So more freezing point for the option number 1 correct. 25 ml of aqueous solution of KCl was found to be required 20 ml of 1 molar silver nitrate for titration using potassium chromate indicator. Depression of freezing point of KCl find out for 100% dissociation. Kf value given. Molarity both are same taken. That means first find out molarity KCl versus AZ NO3 titration. M1 V1 is equal to M2 V2. M1 find out V1 25 ml, M2 1 molar into 20. Therefore M1 is equal to 20 by 25. 0.8 molar. Now depression of freezing point. Depression of freezing point delta TF is equal to Kf into molality into I factor. I factor is equal to 2 because K plus and Cl minus, complete dissociation. So Kf value given here 2, molarity 0.8, I factor 2, 3.2. That is option number 2. 1C electricity deposit. 1C means 1 coulomb. 1C means 1 coulomb. That means we have two definitions in the electrochemistry, small e and capital E. Small e is called ECE. ECE full name is called electrochemical equivalent. That is the mass deposited for 1 coulomb charge. Capital E is called equivalent mass or equivalent weight. That is a mass deposited for 96,500 coulombs of charge. So here question given only 1 coulomb of charge. 1 coulomb of charge always equal to 1 electrochemical equivalent. The relation between them is now small e is equal to capital E by 96,500. If you want to find out silver equivalent mass 108 by 96,500 for silver. But here mass 10.8 not correct. It is correct given as statement only, electrochemical equivalent of silver. So ECE is electrochemical equivalent, symbol is small e. Capital E is called equivalent mass. Equivalent mass deposited for 96,500 coulombs. Whereas electrochemical equivalent is a mass depositing for the 1 coulomb of charge. So 1 C means 1 coulomb of charge. Nothing but 1 electrochemical equivalent. That is answer 3. So standard electrode potential data you are given, that is used for stability of oxidant and redox reactions, titrations, half cell reactions, values also given here. Permanganate is 1.51, that is addition of electron is called reduction potential, SRP values. This also SRP values Fe3 plus by Fe2 plus. I think this is small correct because Fe3 plus by Fe2 plus in NCERT wise given as point, the reverse given. This is 0.77 volts. This is 1.38 volts. This reverse given because in the textbook wise Fe3 plus by Fe2 plus is 0.77 volt. Chlorine is 1.38 volts. Highest SRP for a non-metal is fluorine, F2, 2.38 volts, but here chlorine 1.38. Dichromate is 1.4 correct one. Now, identify the only incorrect statement in the regarding estimation of aqueous ferrous nitrate. Aqueous ferrous nitrate means ferrous is converting into ferric in the titrations by the action of potassium permanganate because oxidizing agent. So this is Fe2 into Fe3. The value given is Fe3 to 2 given. That is reduction. We want oxidation. Then the value is called oxidation potential minus 0.77 volts. Permanganate value is MnO4 minus in acid medium converting into Mn2 plus. This is called reduction because plus 7 into plus 2. Reduction value of this is given directly. Reduction potential equal to 1.51. Therefore, net value is called OP plus RP. That means E naught of cell is equal to construction of these two. E naught OP plus E naught RP. OP value minus 0.77. This is 1.51. Gives some positive value. Means titration is possible because positive value is called spontaneous reaction. Reaction occurs. But don't use HCl medium because this is called H plus medium set. But H plus ions cannot be taken as a HCl. Why? Because suppose use HCl medium, then it is also involving in the reaction. HCl using. That means permanganate MnO4 minus plus H plus ions into Mn plus 2 is 1.51. Now chlorine also undergoes oxidation, Cl minus to Cl. 2Cl minus into Cl2, that is called OP value minus 1.38. This also gives positive value. No? So sum of these two also use positive value. E naught of cell is equal to again positive value obtained. That means if you use HCl medium, medium also participate in the redox reaction. then calculation goes wrong because we want only oxidation of Fe2 plus into Fe3 plus, that is the oxidation requirement with the help of permanganate in the presence of acid medium. Medium should not participate, but here medium also participate because this value is also given positive value. That's why in the titrations of permanganate in acidic medium, don't use HCl as a medium. Use sulfuric acid better, but not HCl, because HCl also undergoes oxidation. So which is incorrect statement means addition of HCl is not correct as a medium. But for dichromate titrations we can use HCl medium, no problem, because 1.38 to 1.4, very small difference, nearly both of them same. That's why for dichromate titrations we can use no problem either HCl medium or sulfuric acid medium, but permanganate titrations don't use HCl as a medium since undergoes oxidation of medium also to liberate chlorine gas with a positive value of E0. That's why HCl cannot be used. Wrong statement is can be used HCl medium, wrong. In a first order titration, time required for 99% nearly. Comparison given. Comparison means first to take the first order formula. T is equal to 2.303 by K log A by A minus X. 2.303 by K. First I'll take time for 99.9% log 100 by 100 minus 99.9 is equal to 2.303 by K. This is log 1000. Log 1000 value means 3.1000. Log 1003. Now compare the first option 10 times to that of half-life. So half-life means 50%. T 50% is equal to same formula 2.303 by K log 100 by 100 minus 50%. 50% means log 2. Log 2 value is equal to 0.3. 2.303 by K into 0.3. That means take the ratio between them, then 2 point cancel, 3 by 0.3, that is nearly 10 times. Correct one? That is 10 times is correct one. Like that you can compare the other options also with respect to first order rate constant formula, but suitable is only first one 10 times, that is 3 by 0.3 is 10 times. So here given confirmation, boat form and chair form given. The reaction is first order for each direction. Equilibrium constant K. K is equal to 10 raised to 4. K formula is forward constant by backward constant. That is symbol given, forward as Ka, backward equal to Kb. Kb or Kc equal to Kf by Kb. K value 10 raised to 4 is equal to Ka by Kb. But here it is given as for the conversion of chair form to boat form. Chair form to boat form means backward reaction. So backward reaction activation energy factor is given E raised to minus E value 4.35 10 raised to minus 8. Therefore, from Arrhenius equation K is equal to A into E raised to minus EA by RT. Now it is nothing but Kb, backward constant. Kb equal to A value given, pre-exponential factor is 10 raised to 12. That is A value 10 raised to 12. This value given, that is fraction of molecules having activation energy is 4.35 10 raised to minus 8. 4.35 10 raised to minus 8. So 4.35 10 raised to minus 8 plus 12 means 4 is the Kb value. Therefore, Ka value is equal to, from this equation, K into Kb. K value 10 raised to 4 Kb value 4.35, 10 raised to 4. Total value 4.35, 10 raised to 8. Okay, that is K value. But question given, find out apparent rate constant. Apparent rate constant Ka plus Kb. It is not 2, it is B. So apparent rate constant Ka plus Kb equal to apparent rate constant Ka plus Kb. This is apparent rate constant only for the reversible reactions. That is forward constant plus backward constant is called apparent rate constant. Forward constant value Ka value 4.38 to 10 raised to 8 plus Kb value 4.35 10 raised to 4. So total value, sum of them 4.38. Suppose take common value, then 10 raised to 8 plus 10 raised to 4 taken as 10 raised to 8 only, 4.35, 10 raised to 8, because 10 raised to 8 plus 10 raised to 4 means to 10 raised to 8 nearly. Answer 2. Okay, so that means first find out the K value. K is given as 10 raised to 4, K by Kb, that is Ka by Kb, Ka value K into Kb. Kb value equal to, from the Arrhenius equation, A into E raised to minus Ea by RT. A value is 10 raised to 12. Ea by RT value given as, that is fraction of molecules having activation energy, 4.35, 10 raised to minus 8. Minus 8 plus means plus 4. Therefore, Ka value equal to 4.35, 10 raised to 8. 4 plus 4, 8. Now, apparent rate constant means sum of the forward and backward constants for reversible reactions. That is so important. Apparent rate constant for reversible reaction. Only reversible reaction. Some of them nearly taken as 4.35, 10 raised to 8, because this is 10 raised to 4, this is 10 raised to 8. Next, in the process of extraction of gold, roasted gold ore, that means it is called crude or gold mineral from the earth crust directly. That is called impure form of gold, crude gold also. On cyanide addition in presence of O2 forms a complex solution. That is called hydrometallurgy to form AuCN taken twice minus 1, because Au plus 1 state. You can use Au or silver also, same type. Next, complex is containing gold displaced by Zn. Zn forms a complex ZnCN taken 4 times Zn charge 2 plus cyanide minus 4, net value minus 2. That is called Y. So Y is equal to zinc cyanide complex, X equal to RS cyanide or gold cyanide complex. AuCN twice minus 1, Zn is twice minus 2. Answer 1. Which of the following statements correct? Milk is emulsion, correct one. Milk is a emulsion, correct one. A gel is a system in which one component at least has a low rigidity and another component has a high mobility, because gel means liquid dispersed in solid medium. So liquid is taken as mobility, high mobility, solid is taken as low rigidity, nothing but gels. Correct one. Peptization is a process. Peptization is a process of purification of chemically prepared. It is not purification method. Peptization is not purification method. That's why 1 and 2 are correct one. That is all except 3. Answer 4. POP bond present. That means 2 phosphorus requirement, hypophosphorus acid, H3PO2. Only 1 phosphorus. Peroxodisulfuric acid, H4P2O8, POOP, OH, OH. Orthophosphoric acid, it is also only 1 phosphorus. We want 2 phosphorus because POP bond. Here POOP bond, peroxy bond present. Pyrophosphoric acid is H4P2O7. That is POP, OH, double bond O, double bond O. It's called pyrophosphoric acid. Doubling of orthophosphoric acid with elimination of water is called pyrophosphoric acid. Doubling means like this. 2 moles of H3PO4 on heating undergoes loss of water to form H4P2O7, nothing but pyrophosphoric acid. So answer, pyrophosphoric acid contains POP bond, POP bond. This contains peroxy bond, POOP bond. So answer 3 only correct. A completely failed sulfuric acid is left unstopped, means stopper is not using. For several days, we observed spontaneous overflow of acid. Because sulfuric acid has more affinity for water molecules, that is hygroscopic. Hygroscopic. Hygroscopic means absorb water. Moist or water molecules. That means volume increases. Volume increases means overflow occurs due to the hygroscopic nature of sulfuric acid. Lanthanides are 14 elements in the 6th period, atomic number 58 to 71, correct one, filling with 4f orbitals, that's a 4f series also. Lanthanides and actinides resemble in electronic configuration, correct one, because they belongs to inner transition elements. Lanthanide contraction is responsible for the fact that zirconium, hafnium have same radius, correct one, because of lanthanide contraction, that is 4d and 5d series having same radius. 4d and 5d series having same radius because of effect of lanthanide contraction. Also correct one. So all of these correct one. Cr2 plus, Mn2 plus, Fe2 plus, Na2 plus, copper2 plus have show magnetic property. Which of them exhibit to minimum paramagnetic? Minimum means less number of unpaired electrons. Water is a weak ligand. That means no need to follow crystal field effect, direct to follow configuration of the element. Manganese plus 2, Mn2 plus, 3d 5 means 5 unpaired electrons. Fe2 plus means 3d 6, 4 unpaired electrons. Nickel 2 plus, 3d 8, 2 unpaired electrons. Copper plus 1 plus 2, 3d 9, 1 unpaired electron. So least number equal to 1 unpaired electron, that's why least paramagnetic is copper complex. Cu 2 plus complex. Which of the following entities of coordination compounds expect to observe low frequency of light? Energy proportional to frequency, that is proportional to strength of ligand. Strength of ligand means strong ligands will give more frequency, means light of more frequency or more energetic radiation. Weak ligands less frequency of radiation or less energy radiation. Strength of ligands wise, we want to, what is given? Lowest frequency means weakest ligand. Which is weakest ligand here means chlorine is a weak ligand. So Cl is a weak ligand. Weak ligand means absorb lowest frequency. Cyanide strong ligand. Next ethylene diamine strong ligand. Ammonia also strong ligand with +3 charge. That's why first cyanide, next ethylene diamine, next ammonia, last chlorine. Cl is the weakest ligand in these 4 options. That's why Cl absorbing lowest frequency. Answer 2. Which of the following sequence of reaction is correct? I think this is NaNH2 or sodium in ammonia. Dehydrohalogenation. Dehydrohalogenation. Elimination of hydrogen and halogen. So here halogen elimination and here H elimination. So A is equal to, right here, A is equal to cyclohexene. Cyclohexene by the elimination of HBr. Next followed by ozonolysis. Break double bond, add OO. It is, question is water given. That is very important one. Water is called oxidative ozonolysis. Oxidative ozonolysis. Zn water is called reductive ozonolysis. Reductive ozonolysis formation of carbonyl compounds, whereas oxidative ozonolysis is formation of carboxylic acids containing hydrogen atom. So here H present, here also H present. That is why both of them converting into, add O2 O2, don't add OO. OO addition for the carbonyl compound, that is reductive, it is oxidative. So both of the carboxylic acids. COOH, COOH. Next, barium oxide, salt formation. This react to the barium oxide, elimination of water from the acids to form barium salt. Barium salt means total 6 carbons. 1, 2, 3, 4, 5, 6 carbons. CO O minus 1, 2, 3, 4, 5. CO O minus joined with barium salt, Ba2 plus. That means hydrogen ions are replaced by barium metal, electropositive metal. E hydrogen ions plus O combined with water molecule byproduct. Next, heating. Heating undergoes loss of barium carbonate. So this on heating. Loss of barium carbonate, BaCO3. Barium carbonate, BaCO3 loss. These two join together. I'll take numbering wise. 1, 2, 3, 4, 5. 5 member cycle ketone. Plus BaCO3, barium carbonate. That is answer 3. So first one is dehydrohalogenation, that is NaNH2 or Na by ammonia. Not simply ammonia. Ammonia undergoes nucleophilic substitution, but it is elimination requirement NaNH3 or NaNH2. Form cyclohexene. Next important one, it is oxidative ozonolysis conducting carboxylic acid formation, not aldehydes. If it is Zn present, then it is called reductive ozonolysis, but no Zn given here. That's why oxidative ozonolysis gives carboxylic acids. Carboxylic acid next react with barium oxide, acid plus base salt. the cyclic salt. The salt now again on heating undergoes loss of BaCO3 combustion. That is called also dry distillation of calcium or barium salts to give cycloketone. Byproduct is very easy, that is compulsory BaCO3 elimination occurs in case of barium salts. Because BaCO3 contains high lattice energy. Therefore, BaCO3 favorable with elimination of cyclic ketone. Answer 3. The reaction of R1-chloro-3-methyl pentane. First structure of that compound. Pentane. Take pent. 1, 2, 3, 4, 5. Pentane. 1-chloro. First one. Chlorine. 1, 2, 3. 3-methyl. 1-chloro-3-methyl pentane. React with the sodium iodide. First, where is chiral carbon here means this is not chiral, this is not chiral, but this is the chiral center because ethyl branch, methyl branch, a different branch. That's why this is called chiral center. But halogen is not attached to chiral center. It's a branch only. It is reacting with the NaI. Finkelstein reaction replacing chlorine by iodine to form 1, 2, 3, 4, 5. There is no iodine. Means chiral center not disturbed. Na? Chiral center not disturbed. So remain same. Remain same means parent product compound equal to just chlorine replaced by iodine in the side branch, but not on the chiral center carbon. Therefore, R remains same as R only. Therefore, answer 1. Nothing but chiral center is not disturbed. So, dehydration, sulfuric acid. First elimination of OH. Cation. Tertiary carbocation direct undergoes elimination or rearrange of same. Methyl shift. Again tertiary only. But this is tertiary having, this is 3 alpha H. This side no alpha H, 3 alpha H. This tertiary halide 3, 3 more. So that is more favorable because each shifting has to give more stability of carbocation. So this is a tertiary, but this tertiary is attached with the 3 alpha hydrogens. This is called CH3 branch is alpha hydrogen 3. But this is having attachment with the 3 plus 3, 6 alpha H. So that is more favorable. But question given as product means it is possible, that is possible. It is possible means on direct elimination forms here double bond. Here any one of the lost to form double bond. So center double bond or terminal double bond. Both 1 and 2 or both A and B. So shifting is possible. Why means if suppose shifting is giving again tertiary carbocation with the same number of alpha H, that means 3, again 3 means shifting is not correct because each shifting has to give more stable carbocation. Tertiary to tertiary possible, but that is to give more stable tertiary carbocation, that is having 6 alpha H. Number of alpha H increases, hyperconjugation also increases, stability also increases. That's why that is more stable one. So possible reaction, but question given as not major minor. If it is major means that is major compound because more stable carbocation. But possibility means both possible. That is 1 and 2 possible. Answer 4. Most acidic compound. Aldehyde is minus I and minus R effective. Meta position only minus I. No resonance at meta position. This is again minus I and minus R. Minus R is common for both ortho and para. Then how to differentiate the effect means inductive. This is close distance, this is long distance. So inductive more working here. More inductive, more electron withdrawing effective. Electron withdrawing effect increases, O minus becomes more stable, easy to lose H plus ion. That means electron withdrawing effect gives resonance stabilized phenoxide, then easily becomes loss of H plus ion working as a strong acid. But is long distance. But one more factor to be considered is called intramolecular hydrogen bond formation. That is expected to be ortho is more acidic than para because more minus effect working on the ortho due to close distance. But in this case, there is additional factor is intramolecular hydrogen bonding. C double bond O and H. This oxygen and hydrogen joined by hydrogen bond. Therefore, difficult to break this hydrogen bond comparison to para because para does not contain intramolecular hydrogen bonding. That's why 3 is more. If hydrogen bonding is not present as per the rule wise, 1 is more acidic. That means ortho is more acidic. But because of hydrogen bonding, it is less acidic. But not less than meta. Less than only para. So first para more acidic, next ortho, next meta. Para, ortho, meta. Is called acidic nature. So most acidic is nothing but para due to absence of hydrogen bonds. RMGX plus carbon dioxide followed by hydrolysis. RMGX possible from both sides, that is aromatic and aliphatic. The reaction is nothing but like this. R MgBr, R minus Mg plus carbon dioxide, C double bond O. Nucleophilic addition takes place, then O into O minus. That is equal to R C double bond O Mg Br. This undergoes hydrolysis. Next step, hydrolysis. On hydrolysis of this compound gives H and OH. That means RCO OH. So carbon dioxide converting into carboxylic acid. This R is only coming from Grignard reagent. Now here, this will be forming Grignard reagent. If possible, it is taken as R MgBr. This is also possible. Aromatic Grignard reagent Br Mg R. That means two sides possibility. Therefore, two sides undergoes carboxylic acid formation. COOH correct, COH correct. Right, answer 2. Highest value of pKb. Basic nature proportional to Kb. Kb inverse to pKb. Highest pKb, least basic. Least basic. Basic nature generally order equal to aliphatic amines are more basic. Aliphatic amines are more basic than ammonia. Ammonia more basic than aromatic amines. That is the order of basic nature. Now we want weak base. So this is aliphatic, this aliphatic. These two aromatic. But in these two aromatic, that is 3 and 4 options. Here lone pair is there. Here also lone pair is there. This lone pair is involved in the conjugation with phenyl ring. This lone pair remains same. So here more available, but here less available. That means electron density is less available here. More means that is strong base. Pyridine strong base than aniline. So aniline is the weakest base in these 4 compounds because it's aromatic compound and lone pair is involved in the conjugation. That's why weak base are least basic. Least basic means most pKb value. Answer 3. Aspartame. Aspartame is an artificial sweetening agent, correct one. Aspartame contains peptide linkage. In the structure contains peptide linkage. Peptide bond also present. So both correct. 2 and 3. For manufacturing of tires, vulcanization with sulfur. 5% sulfur only. This constant value 5% sulfur. In the textbook wise also constant value. It's memory based only. 5% sulfur, you have to remember that value. A button cell used in watches functions as following reaction. Half cell potential value given Zn2 plus 2 electron Zn. Means reduction potential is given minus 0.6. This is also reduction. But in the process, Zn is 0, Zn2 plus. So 0 to 2 plus means it is undergoing oxidation. Silver is plus 1 to 0. Silver plus 1 to 0 is called reduction. Therefore, E naught of cell is equal to E naught OP plus E naught RP. Reduction potential plus oxidation potential. Zn undergoes oxidation. Therefore, oxidation potential of Zn is equal to reverse plus 0.76. Reduction potential of silver oxide, direct value 0.34. 1.1 volts. E naught of cell, E naught OP plus RP. Oxidation potential for Zn because Zn undergoes oxidation. Silver reduction only. So answer 4, 1.1 volt. Next, cheese is an example of. Cheese is a gel. Belongs to liquid in solid. Foam means gas in solid. Emulsion, liquid in liquid. Solid sol, solid in solid. So cheese example of liquid in solid. Next, 1.73 magnetic moment. Mu is equal to 1.73 root of n into n plus 2, root of 1 into 1 plus 2, root 3. Means 1 unpaired electron. Copper 2 plus contains 1 unpaired electron because copper is having 3d 9. 1 unpaired electron. Titanium plus 4. 4 is 0. 3d is 0. Nickel 2 plus pairing occurs because strong ligand. Due to strong ligand. Cobalt more electron because we want only 1 electron. 1 electron means this one. Cobalt is weak ligand only, but it is x minus 6 equal to minus 4. Cobalt 2 plus 4 s 0. 3d7, 3 unpaired electrons. So correct answer only copper complex, 1 unpaired electron. Next, which of the following will produce methyl alcohol on treatment with hot HI? Methyl alcohol, hot HI. Generally this reaction is SN2 reaction. Reaction of HI or HBr is SN2 except with tertiary and benzyl alkyl group where it is SN1 due to stable carbocation formation. Stable carbocation formation. So we have to verify first to tertiary because we want methanol is a product. Means nucleophile has to react with the carbon side. This is tertiary branch. So this one undergoes carbocation formation. First step, CH3, C plus, CH3, CH3 plus, CH3O minus. React with HI, H plus and I minus. I minus reacting here, H plus reacting, that's it. Is equal to CH3, tertiary butyl iodide plus CH3OH, methanol. Otherwise, it's reverse reaction. Suppose if taken here, iodine added to this site, ascent reaction. That means here iodine and here H, because this follows ascent reaction. Ascent reaction is more react for methyl. Methyl next primary, secondary. That's why methyl react with SN2 with iodine. But this is only exception. The tertiary and also benzyl groups. This is also ascent reaction. This is also ascent reaction. This only SN1 reaction. So answer 2 due to stable carbocation formation. N2Cl is eliminated by heating with H3PO2. H3PO2 and water. Lactose is a linkage between C1 of galactose, C4 of glucose, beta D galactose and beta D glucose molecules. The structure of the lactose only, because we have the syllabus 3 compounds, so lactose, maltose and also sucrose, disaccharides. Lactose is a combination of galactose and glucose, beta D, but 1 of galactose, 4 of glucose will form glycosidic bond, is a constant. Orlan is a polymer of polyacrylonitriles. Polyacrylonitrile. CH2 double bond CH CN is called acrylonitrile. Polymer means is called Orlan. Acrylonitrile, because single unit is called acrylonitrile, vinyl cyanides. Acrylonitrile. Answer 4. A reaction of zero order is take place 160 minutes for 80% completion of reaction. The rate constant is. For zero order reaction, K is equal to X by T. That means A gives rise to B, A0, A minus X, X. K is equal to X is 80%. 80% completed means X will 80% formation. Time 160 minutes. One by 200. Sodium metal crystallized in the body center cubic lattice BCC. 4.29 is edge length. That is A value given 4.29. What is the length of body diagonal of the unit cell? Body diagonal length equal to A root 3. A value given 4.29 into root 3. 7.44 angstroms. Same unit, no conversion. 7.45 angstrom, because the length of the body diagonal is A root 3. A value given directly A root 3. Suppose radius is given, then use radius formula R is equal to A root 3 by 4. Then find out A value. But here no need to, directly A value is given. Number of lone pairs, bond pairs. Lone pairs and hybridization of XeF6. XeF6 First, to take the valence electrons. Xenon 8, 6 fluorine 6 into 7, 42 plus 8, 50. ఈ valence electrons greater than 8 divided by 8, less than or equal to 8 divided by 2, till remainder is 0 or 1. Remainder is 0 or 1. That is one easy method to find out the hybridization. Now 50 means greater than 8. Now divide by 8. 50 by 8, 8 6, 48. Remainder is 2. But we want remainder 0 or 1. Once more division. But the value is 8 2. 2 means less than 8. So less than 8 divided by 2. So second time division with the 2. 2 1 2. Sum of quotient plus remainder. 6 plus 1, 7. 7 means 7 hybrid orbitals. S1, P3, D3. sp3, D3. 7 hybrid orbitals involved in the combination S orbital, 3 p orbitals, 3 d orbitals. sp3, D3. And in the summation, if first value is bond pairs, 6 bond pairs and 1 lone pair. So this formula used both to hybridization and also bond pairs, lone pairs directly. That is, first find out the valence electrons. 8 for xenon, fluorine 7, 6 fluorine 6 into 7, 50 electrons. Above 8 divided by 8, below or equal to 8 divided by 2, till remainder is 0 or 1. Then add quotient plus remainder. That is 8 plus 6, 8 into 6, 48 to 2 remainder. But second time division with 2, because 2 value is less than 8. Till we want 0 or 1. So 0 obtained as a remainder value. Now add quotients only. 6 plus 1, 7. 7 means 7 hybrid orbitals. That is s orbital, 3 p orbitals and 3 d orbitals is 7 hybrid orbitals in the formation. And is some value, first value is called bond pairs, second value is called lone pairs. 6 bond pairs and 1 lone pair. sp3d3 and 1 lone pair. E amides are weakest bases. This amide. Weakest base than even aromatic compound also due to resonance. Due to resonance or conjugation. That means this lone pair is involved in the resonance or conjugation with oxygen. This is sp3. This is sp2. Both aliphatic. But sp3 more basic than sp2 because sp2 means more s character, more nuclear force of attraction, will not permit to donate the lone pair of electrons. That's why sp3 nitrogen is more basic than sp2 nitrogen. sp3 nitrogen is more basic than sp2 nitrogen regarding the basic region. So x more than z, z more than y. That is x more than z, z more than y. Excess of chlorine, how many dichloro products are formed in the above reaction, including stereoisomers also. So write the structure of possibilities. Now this is chiral center because chlorine, hydrogen, this is CH2, this is CHCl. So different. This was chiral center, 2 chiral centers. So number of optical isomers equal to or stereoisomers equal to 2 raised to n, 2 raised to 2. Next molecule, not a chiral center. Next molecule, this is also chiral center, na? 2 raised to 2. 4 plus 4, 8 plus 1, 9 isomers. This one both are same. That's why 1. 9 isomers present. Lesson test for nitrogen will be failed. This is not given because not organic compound or not having carbon. Not having carbon. Because Lesant is given by carbon compounds having nitrogen atom. So nitrogen present but no carbon. That's why not giving. Which of the following aldehydes with respect to their reactivity towards addition reaction is given? Nucleophilic addition depend upon the nucleophilic addition proportional to minus I minus R effect. Because C plus O minus. This is more positive charge then this carbon is called more positive charge. More positive charge, more easily attacked by nucleophiles. That's why proportional to minus I minus R effect. Therefore, nucleophilic addition order is equal to formaldehyde highly reactive. Next to other aldehydes. Next to aromatic, because aromatic gives resonance stability. Therefore, aliphatic aldehydes more reactive than aromatic aldehydes. After that one, ketones. RCOR. Ketone less reactive than aromatic ketones. So least reactive is aromatic ketone because two sides aromatic is highly stable carbonyl compound. Does not undergo addition reaction. Now we want to minus effect. This is minus I, this also minus I. But this is aliphatic, this is aromatic. Aliphatic is more than aromatic. That means 4 more than 2. 2 more than 1. Because this is plus I effect. Plus I effect means decrease the positive charge. Decrease the positive charge means less positive, less easily attacked by nucleophile. That means inversely proportional to plus I and plus R effects. That is why answer equal to 4 more than 2, 2 more than 1, 1 more than 3. 2. Benzyl chloride. C6H5. CH2Cl. Sodium cyanide. Nucleophilic substitution. CH2Cn cyanide. Next, reduction. Use pH CH2 NH2 1 2 2-phenyl ethanamine 2-phenyl ethanamine. Common name is taken as alpha beta. Alpha carbon, first one, this beta. Beta phenyl ethylamine. Beta phenyl ethylamine. That's answer 2. Zn zinc blend. Zinc blend roasting first. ZnS on roasting. ZnO. ZnO with the coke reduction. Zn plus CO. Roasting followed by reduction with coke or carbon. MnO4 oxalate to form KMnO5 electrons during process. KMnO4 required to oxidize 126 grams means it is 1 mole. MnO4 minus Mn2 plus N factor equal to 5. Oxalate C2O4 minus 2 into 2CO2 2x minus 8 2x equal to 6. Take 2x value because C2, 2 carbon atoms in the formula, that is 1 mole of the compound, will be involving 2 carbon atoms. So take the same number of carbon atoms in the calculation, 2x value plus 6. E side also 2x value, x value plus 4, 2x value plus 8. So difference equal to n factor equal to 2. Now cross multiply n factors to find out net stoichiometry. That is into 2 into 5. Therefore, resulting equation equal to 2 moles permanganate plus 5 moles of oxalate is equal to 2 Mn plus 2 plus 10 carbon dioxide. So 2 moles react with 5 moles. Then 1 mole react with x moles. X equal to 5x equal to 2 by 5, 0.4 moles. In the refining of silver by electrolytic method, what is the weight of 100 grams of silver anode if 5 amps current passing for 2 hours? Purity of silver is 95%. That means electro refining of metals, impure metal is taken as anode, a pure metal taken as cathode. On passing current, silver undergoes oxidation. The same silver deposit on cathode. That is called pure silver is deposited on the surface of cathode. So loss in mass at anode equal to gain in mass on cathode. Loss in mass at anode equal to gain in mass at cathode is called electro refining of metals. Now it is first 100 grams taken with 95% purity with the current of 5 amps. First Faraday's first law, M is equal to ECT by 96,500 to find out the mass deposited or mass dissolved from the anode. Equivalent mass 108, current is 5 amps, time is 2 hours, 2 into 60 into 60 by 96,500. That is mass giving nearly 40.29 grams. 40.29 grams. If it is a 100% pure sample. For 90% sample, for 95% purity, mass of silver is equal to 40.29 into 100 by 95%. That is giving nearly 42.41 grams. So that many grams are dissolved into the solution. 42.41 grams. 42.41 grams deposited. Balance amount present on the anode surface. Therefore, balance amount present on balance amount of anode 100 taken, 42.41 dissolved, that is deposited that side, 57.59. present on the surface of that anode. Analgesic means reduce the body pains without causing addiction, and modification means narcotic to non-narcotic. Narcotic drugs will give addiction, but non-narcotics not giving addiction. That is, it is without causing addiction. Means it is a non-narcotic. Non-narcotic is best one aspirin and paracetamol. Phenacetin also, but in the syllabus we have aspirin and paracetamol. Paracetamol is N-acetyl paraminophenol. Perchloric acid formula is HClO4. Oxidation number plus 7. The element does not have N-1 D10 NH2 electrons. So which is not containing. This is Zn, cadmium, mercury. These are having D10 configurations. But the copper is having 4s1, 3d10. Trans elements least enthalpy of atomization means soft metals. Zn is soft metal. In 3D series, least enthalpy of atomization for Zn and manganese, because they have stable configuration. All electrons do not take part in the bond formation. That is why very soft metals are Zn and manganese. That is the answer, Zn. That is the reason taken as due to weak metallic bonds. Due to weak metallic bonds, which is due to stable configuration of D10 and D5 orbitals. That's why Zn and manganese are called volatile metals. Phosphorus acid, direct value 3, x minus 6, x equal to 3. But given here two options, plus 3, that is mistake. Example of solid stole. Solid sole, it is gem, not gel. Gem. Gemstone, solid sole. Hair cream is emulsion. Butter also emulsion. Paint is a sol. Solid in liquid. Okay, thank you.